This is a screenshot of an actual conversation I had with Claude, and it represents why my life is so frustrating right now. The LLMs tend to take the shortest path or the least energy path to solving an optimization problem, and it results in this kind of stuff. And it really doesn't allow you to have confidence in the code that it generates because it's really just trying to satisfy a set of criteria. So Purlin is trying to give more confidence in that process. And between Purlin 0.8.5 and 0.9.0, I'm taking a very different approach. The spec-based creation of software helps make better software, especially if there's tests involved. But the quality of the tests and the ability of AI to write its own tests, those introduce so much variability into the quality of the code that comes out that I had to take a different approach. It can't be, loose, undefined ways of describing tests. It has to be qualified a little bit more. And so this is where the rule proof based methodology that we're introducing in 0.9.0 comes into play. It's not perfect. But I want to get to a point where when you see green across this board, you feel really good that a meaningful set of proofs have been proven and tests have been run to make the test adhere to the specs that you've put in. And so just wanted to talk about a little bit more about that next version. This is not released yet. We're still working on it. But there are essentially three major functions that help bring this stuff together. Instead of the current version of Purlin that has the separate roles and responsibilities, the big change here is that you're allowing AI to be AI, do what it needs to do, interact with it however you want, and bring it together, bring specs and code together at key points in the software development lifecycle. And the ways that you do that are with three methodologies. One, drift, which is look at the code and look at the specs and see what code is not represented by specs. That is a drift command. There is validate and status, which sort of work together. Status basically says how many of your rules in your files, and I'll show you what a rule looks like here. So this is a rule, which is essentially a specification and a proof that goes along with the rule. How many rules have proofs? Here's an example here of a rule that does not have a proof. And so that allows status and validate allow you to test the proofs, validate and pass or fail them, and seal them with a very specific SHA-256 hash that says this is the state that it was in when it was passed, and if code has changed or specs have changed since then, it will not match, so you know that it's a stale pass. And so that's essentially what status and validate do. Is it goes through the coverage and it figures out if the coverage is passing or not. So between drift and status, you get this idea of, are my specs matching the code, and is the code covered with tests that are passing? But the thing that helps prevent this is the third major function, which is audit and the proof integrity. And so this is a set of rules which can be extended. You can add your own criteria during project setup and at any time to these criteria, but we're trying to ship with a really good set of criteria here that effectively do a deep analysis of each of the proofs that are in your specifications and label them as strong, weak, or hollow, which essentially means hollow is just useless. It's assert trues, really. Weak is checking for presence or existence, and is good for certain cases. And strong is running something and seeing the output of it, really actually running the real code and doing the real check. And so when you run that, and status is very cheap, audit is very expensive. So audit takes, depending on the size of your code base, minutes, maybe hour to run. So you don't do it all the time, but it's something that helps you really understand, are my proofs good, and do they help me really ensure the code coming out is solid. This dashboard is optional. You don't have to use it. It's a static HTML JavaScript that reads from the existing tools that are generated and used by the CLI. And so in here, I ran audit, and this is what is reflected in the dashboard, but it's really right in the in the tool as well. And the nice thing is that it tells the LLM, here's how you fix this stuff. This is why it's hollow, or why it's weak, and why it's high. And you can basically tell Claude, hey, take a look at the audit summary, go and fix this stuff, make strong proofs, and come back when it's all 95% or higher proof integrity here. And that works. But you're still trusting the LLM to write those proofs for you. And it's okay. But again, it's a liar. You can't trust it. And so this is where we're taking the concept of anchors that has been in Purlin for a while and extending them a bit. Anchors are the same thing. It's still rules and proofs, but you can have them locally. And so they're almost like include files, right? You can have include files that are here. So this is an example of a required rule proof, but it comes from one of the anchors. So it's basically an include. You could have global and locally scoped includes, but you can optionally have an anchor hosted remotely in a Git repository or in a different service. So we have a Figma version of this too, that Figma becomes like a remote anchor, but that's sort of a special case for visual stuff. But for most of these, you can have it hosted on a Git repo, and the LLM can't touch it, right? It gets imported, and it is what it is. And so you imagine things like security rules and proofs. You can imagine things like a architecture statements. You always must have localization abstracted into separate files, and not hard coded into the code, for example. That's an example of like an architectural decision. Requirements from product managers. You can have a set of criteria that to a product manager mean if the rules and the proofs pass, then it means that it is satisfying the product criteria for the product. And that can all be hosted in Git repos. And here's an example of one that's hosted, and it's stale because the Git repo has changed and it hasn't synchronized locally and have the latest copy of that. So that's an example of how Purlin moves from just a spec code process that allows LLMs to write more trustworthy code into something that's collaborative. Haven't tested this extensively yet, so I have to get to a point where we're actually trusting the core process here, and it stays out of the way, which I think that's very good right now. It stays out of the way, but does it? When this whole dashboard is green, or when all of your reports here are green, do we have good code? And I don't think it can be hands-off. I don't think you can now suddenly say, oh, everybody just tells the LLM what to do and this will just take care of it. I think it still has to be a critical process where humans have to think. And I actually think that the QA role amplifies, because they're the ones that can go through here and say, do I feel that the proof integrity is good, and can I write better versions of these things that actually do full end-to-end tests that really up the proof integrity and make it all better. So I think it gives people that are collaborating on these things the right tools and the right thought process to go into making better code come out. Does it all work together in a project that can, when the dashboard is green, everybody's happy and the code works? Don't know yet. So we're going to continue to push on this and experiment, and I'll release this at some point to the GitHub repository as well, so you guys could try too.